Okay, so let's have a look at a more complicated example of using a while loop. As always, we will combine this while loop with other elements we have already learned. So we will create a function which determines whether a specific argument, specific number, is prime or not. So how this function works? Well, maybe let's first have a look at some examples of usage of this function. I will run it. First define this function. If the number is negative, we by default get false. 1 is not a prime number. Maybe just as a reminder, prime number is a number which can be divided only by 1 and itself. So for instance, number 4 is not a prime number because it can also be divided. It can be divided by 1, by 4, but cannot be divided by. But it can be also divided by 2. 5 is a prime number because it can be divided by 1, by 5, and nothing else. So 2 is also a prime number. 7 is a prime number. Well, for small numbers, it's actually easy to determine whether a number is prime or not. But for a number like this, well, not so easy, even for a mathematician like me. This number, okay, it's easy because it can be divided by 2 because it ends with 2, so we should get false, and indeed we get false, so it seems like our function works properly. So now let's have a look how we actually got this behavior. So we define a function, it takes one argument, these are these numbers, and what happens next? Well, first, this is like nothing new. First we do some preliminary checks using conditional statements. Namely, we check whether this number is smaller or equal than 1. If this is true, then we create a prime variable called prime, which is equal to false, and as you will see in a minute, this will be the result of our function, because by default, when the number is smaller or equal than 1, our result should be false. If this is not the case, if x is not smaller or equal than 1, then we kind of assume that our number is a prime number, and then we will check step by step whether our assumption was correct or not. So this is a philosophy you might encounter a lot in your programming experience. So basically, you assume that something is something. With logical expressions, you usually assume that something is true, but sometimes you can also assume that something is false if it's easier for you to think about this way. So here we assume that if x is bigger than 1, then we assume that it's true, and then we will use a while loop to check whether we should change our assumption. How do we do this? Well, we have to check whether x can be divided by anything else. While prime and I is smaller than x, what happens here? Well, this is where you can understand why this assumption was important, because here we check two things and both of them have to be true. First of all, we have to check whether our assumption was correct. So we check whether our assumption was that the number is a prime number. We check whether so far we still have a hypothesis that the number is a prime number. So imagine in a specific case, if x was negative, then prime is false, so this will be false, and no matter what happens here, this entire logical expression will be false, and so this code won't be executed. Python will move on here and return the value prime. And the value prime is false because x is negative. So basically we get for any number which is smaller or equal to 1, by default we get the answer false, because Python goes here, prime is equal to false, and then while loop is never executed because prime is false, and this logical expression evaluates to false. What happens if it's otherwise? So what happens if x is bigger than 1? Well, then our assumption is that prime is equal to true. So this is equal to true. So imagine that x is 10, then this is true, and our I currently is 2. 10 is bigger than 2, so we have true and true, so the entire expression evaluates to true, and so Python goes in here. And then it checks whether our x, so in our case it was 10, divides divides this 10 by 2, we get 0, we get 5 and the rest is 0. This is a modulo operator. If you remember from the first notebooks, it returns if I divide something by the modulo operator. For instance, here 10 divided by 2, I get 0 because I get the rest of the division. So for instance, 11 divided modulo 2 is equal to 1, because I can divide 10 into 2's, and I'm left with one thing which I cannot divide by 2. So here, if my modulo operator returns 0, I check whether this result is equal to 0. I have to change my hypothesis, because if modulo operator returns 0, it means that this number can be divided by this number, right? Since there is no nothing left after the division, therefore this number can be divided by this number, and since my I was smaller than my number and it wasn't equal to 10, I should change my hypothesis that this is not a prime number. Now let's see what happens if I indeed have a prime number. So for instance 5. Well, again, 5 is greater than 1, so my assumption is that this is a prime number. I go here, I is equal to 2. This is true. 2 is smaller than 5. What is the division of 5 divided by 2? Well, it's not 0, so Python skips this code and increases I. We go back at the beginning. Prime is still true because Python skipped this part of the code, because the division was not, the modulo operator didn't give 0 as a result. And I increased to 3. 3 is still smaller than 5. I check what is the result of 5 modulo 3. Well, it's 2, different than 0. Python skips this code and goes here. Increases I by 1. I get 4. And we go back to the beginning. This is still true because this code was skipped. 4 is still smaller than 5. Python executes this code. We check what is the result of 5 modulo 4. It's 1, different than 0, so this code is skipped. We go here, I is increased by 1, we get 5. Prime is true. I is equal to 5 right now. 5 is not smaller than 5, so this expression evaluates to false. So Python finishes the while loop, skips this code, does not execute it, and goes here. Prime is equal to true. So the only thing left is to return prime, return the value of prime. The value is true, so we get that 5 is a prime number. We can check that is prime of 5 returns the value true. Yeah, so for those of you who are not familiar with prime numbers, I guess this example might have been a little bit more difficult. As you can see, while loops are a little bit less intuitive than for loops. You kind of have to think about everything at once. So when we are creating these preliminary checks, we had already the behavior of while loop in mind. So the fact that we define prime variable as true here didn't mean that we already know that the number is a prime number, only that we assume that it's prime so that we can perform the while loop until until we are not corrected. And if we are not corrected for the entire while loop, then the answer is yes, indeed this number is a prime number. If at some point we find that modulo operator gives us 0 along the way, then it means that the number can be divided by something else than 1 and itself, and so the number is not prime. Yeah, so if you think it was difficult for you, try to rewatch this video, try to figure it out yourself. And in the next video, we will talk about two other new useful keywords which you can use in loops, either for loops or while loops. And these are continue and break, which allow you to get some new behavior using loops. So thank you for your attention and see you in the next video.